In this problem, 3 trains are moving together to the east. If we consider the east to be to the right in our diagram, the 3 trains are moving to the right with a speed of 2 meters per second. So let's call the speed of these trains speed 1, 2, 3, and it's 2.0 meters second. A fourth train traveling to the east catches up with the 3 initial trains, so the fourth train will be around here, and it travels at a velocity of 4 meters second to the east. Train 4 will eventually collide with trains 1, 2, and 3, and they will stick together and move as one object. A moment later, trains 1, 2, 3, and 4 will catch up with train number 5 that is initially at rest. So the velocity of train 5 is 0. And the question is, what is the speed of the 5-car train? So after the trains stick together, we would like to know what is their final velocity that we can represent as velocity 1 to 5, and this is what we would like to find. So this is a collision problem. Momentum must be conserved. We have an initial time and then the final time. So if momentum is conserved, the final momentum must be the same as the initial momentum. So the final momentum is mass of trains 1 to 5 multiplied by the velocity of trains 1 to 5. They are moving as a single object. At the initial time, the total momentum will be the mass of trains 1, 2, and 3 multiplied by their common velocity, then the mass of train 4 times its velocity, and the mass of train 5 multiplied by the corresponding velocity. However, since train number 5 has 0 velocity, the last term will cancel. Since we know that the cars are identical, that means the mass of the cars is identical. They have the same mass. So if each train has a mass m, the mass of trains 1 to 5 will be 5 times m. The mass of trains 1, 2, and 3 will be 3 times m. The mass of train 5 will be simply m, and the mass of train 4 is m. So replacing those values for the masses in our equation, we have 5 times m initial velocity of trains 1 to 5 moving together, 3 times m for trains 1, 2, and 3 times their common initial velocity, mass of train 4, and mass of train 5 multiplied by 0 is 0, so we don't have to put it in our equation. If we divide by mass both sides of the equation, we see that the mass of the trains actually will cancel, and the equation simplifies to 5 times velocity 1 to 5, 3 times velocity 1 to 3, and velocity 4. Since we want to find velocity 1 to 5, or the velocity of trains 1, 2, 3, and 5 after the collision, moving together as a single object, we isolate velocity 1 to 5. So after dividing by 5, we have this equation. And all we have to do now is replace the initial velocities for trains 1, 2, and 3 moving together, velocity of train 4, and after doing this math, we get the final velocity for trains 1 to 5 moving together, and you get 2.0 meters per second. So this is the velocity of the 5 cars stuck together. What is important to remark here is that between the initial and final time, car 4 collided with cars 1, 2, and 3, but we don't have to calculate the conservation of momentum in that intermediate stage. All we want to do is identify what is the initial configuration of the system, the final configuration of the system, and apply conservation of momentum between those two different times. So you don't have to do intermediate steps to calculate what were the conditions after train 4 collided with trains 1, 2, and 3, and before those 4 trains together collided with train number 5.